This is one of your geometry proofs. We're doing it by deductive reasoning, so we're going to have to make a statement, have a reason for why we believe this to be true. So, it could be, these two angles are the same because they're vertically opposite. So you will point out which angles you believe to be the same. You must clearly state it using your mathematical language, and then back yourself up. Once you make a statement, you must back yourself up. So this is Theorem 11, and if you look in your book, you can go through it that way. I'm sure there's plenty of other videos online. I'm going to go through it here bit by bit. And again, there's structure to a proof. You have to talk about what you were given. So this will be the statement in your exam. From this, you will talk about what you were given, what you're trying to prove, any constructions that you're making to your diagram, and your proof. So Theorem 11 is if you have three parallel lines. So I'm going to go with my diagram first. So I'm hoping there in my diagram my lines look parallel. I'm going to mark them off as parallel. You have three parallel lines and they cut off equal segments on some transversal. So let's just draw in any transversal. Let's go for this way. I'm going to label that point A, that one B, and that one C. And what do we know? Three parallel lines have cut off equal segments on some transversal line. So that and that are equal. So the length of A to B is equal to B to C. So that's my diagram. And what I need to draw in is then they will cut off equal segments on any other transversal. So let's draw in another transversal. I'm going to just draw in one here, it doesn't matter. I'm going to call that D, E, and F. So what I'm trying to prove now is that DE is the same length as EF. So I was ignore this for a second. If I have three parallel lines and they cut off equal segments on some transversal, then they will cut off equal segments on any other transversal. This is the part that I'm hoping to prove. So this is kind of what I was given. And this bit is what I'm trying to prove, that DE is equal to EF. And I'm taking all of that from the statement here. I wouldn't learn anything off. I just need to understand how to take the statement and work with it. Just in case the converse of this theorem is actually true as well. Converse means the reverse. So if you have equal segments, if we know that DE was equal to EF and AB was equal to BC, then we know we have parallel lines there. Right, so given to prove so what were we given? It's all here. But I need to write it mathematically. What are we trying to prove? It's all here, but I need to write it mathematically. Am I going to perform any construction to my current diagram? And then I'll do my proof. Hopefully that's clear. So So what was I given? Well, I was given, let's say the line there, if we look at it, it's a line through the point A and D. So we were given a line AD, and that line was parallel to BE, which is also parallel to CF. There's my 3 parallel lines. What else was I given? So it's all here, written in English. You have to write it mathematically. So we were given 3 parallel lines that cut off equal segments. So I'm just going to put a little comma there, and I know that AB, that line segment, is equal to BC. Okay. Maybe just a side note here. I'm just going to put it up here. AD is that full line going through A and through D. That's the line segment starting at A and going to D. And that's how we explain it. So the line AD, so this full line all the way through going on to infinity either side, is parallel to BE, which is parallel to CF. And what are we trying to show? We're trying to show that the line segment from A to B is equal to the line segment from B to C. Or another way of saying that, just in case maybe this is easier or more familiar, the length of AB is equal to the length of BC. Whichever one of those you'd prefer. Probably go with this one because it's more familiar. What am I trying to prove? Well, it says it here. The length of DE is equal to the length of EF. What construction am I going to put in? So this is the only part that I have to, I suppose, have some familiarity with. After this point here, my proof, I should be able to just use my geometry information, that all my geometry rules from junior cert, and be able to do the proof. So none of this I would learn. Given is this bit here. You need to write it mathematically. What you're trying to prove is this bit here. You need to write it mathematically. And your diagram comes from the statement as well. Your construction. Okay, I need to know maybe what this. So put a little star beside it, because this is the part that I suppose I maybe do need to have some memory of, or know kind of how I'm going to go about this. So my construction, I'm going to draw a line that is parallel to this line here. And I'm going to put it through the point A. So I need to have that line parallel, and it's going to go through the point A. And let's call these, in your book I think they call them like E dash, F dash, I don't like that. I'm gonna go for L and M. And the next thing that I want to do is I'm going to draw a line could draw in another line that would be parallel to this one maybe. I'm going to write this in first anyway. So what have I done? I've drawn a line and I'll call it AM, and it's parallel to DE, and it cuts EB at L, at the point L, and it cuts this line too at M. So the line CF at the point M. I don't think I can be any clearer than that with what I'm doing. Okay. I think then if we draw in another parallel line, except this one's going to be parallel to this one and it's going to go through M. So now that's going to create more points. I'm going to call that N and P. So I might move my proof down just a little bit because there's a bit more to my construction here. So what else do I want to do? I want to draw MP, and MP is parallel to AB. So this line here, MP, is parallel to AB, and it cuts so this line through M cuts BE, or EB, maybe I'll go EB because that's what I said before, EB at the point N, and what did I say before? No, I didn't. AD and the point, and the line AD at the point P. Again, I don't think I can be any clearer than that for the examiner. So that's just setting it all up, explaining mathematically exactly what I'm doing. As I said, maybe this is the only bit that I need to actually know how I'm going to approach this. And the reason that I am doing this is because now I'm creating triangles here. If you look there, triangle, triangle, or if you look here, triangle, triangle. So I'm going to use maybe, what do you call them, congruent triangles in this situation. going to see if I can try and prove that some of these triangles are congruent. So let's go with our proof. Right, so what do I know? I certainly know that that angle there is the same as that angle there. Okay. And how do I know that? Now let me just name that angle. So it's the angle that starts at B, goes to L, ends at A. So the measure of the angle BLA is equal to the measure of the angle, sorry now, can you see how I'm writing that? The measure of the angle NLM and again I need to back myself up. They are vertically opposite angles. Okay. AB is equal to BC. Therefore, sorry now, so I just want to make sure I'm explaining this right. So I'm going to say it first. So AB is equal to BC. How do I know that? Well, that was given in the question. But then you can tell that BC and NM are equal. And the reason that we can tell that is because here we have a parallelogram. So these two lines are parallel. These two lines are parallel. Therefore, we have a parallelogram. What do you know about opposite sides of a parallelogram? They are equal. So AB is equal to BC. That was given in the question. BC is equal to NM because they are opposite sides in a parallelogram. Now you can do this in a different order. I actually think the book is probably doing in a different order to me. Opposite sides of a... But as long as you explain yourself clearly, write it all mathematically, do it as clearly as possible. So what do I know now? Therefore, AB is the same as NM. Because if that's equal to that and that's equal to that, those two have to be equal to each other. Which means now AB and NM are the same. So now we so far, in trying to prove maybe that these two triangles here, the little ones, are congruent. We have proved a side, an angle. What else can we have a look at? Any chance? Okay, so we've parallel lines, so now I see alternate angles. So here's my Z, if you can see it. There, tucked into the corner of the Z. Those two angles are going to be equal. Now, if we describe this as BAL. So the angle BAL is equal to NML. They're alternate angles. Well, then by default I automatically know that these two are the same. They're just the third angle, the third angle in a triangle. So ABL, therefore the angle ABL is equal to LNM. And that's because the three angles in a triangle. I guess maybe I'm not explaining that very well. You know, if that's the same as that and that's the same as that, then those two have to be the same as each other. So maybe you can just say the angle is in a triangle. And okay, so now we have angle, side, angle. So now we know that the triangle ABL is congruent, so that's your mathematical symbol for congruency, to LMN, and that's by angle, side, angle. So we've just shown that. Therefore, AL is equal to LM. Think about it. If that's equal to that, and that's equal to that, and that's equal to that, so we're saying they're exactly congruent triangles. So AL is equal to LM. But we know that that's equal to that. And we know that that so see now, if we know that, I'm trying to mark them, I might have made them a bit small. See this, AL is equal to LM. And we know that then they're equal to each other. Well, they're also equal to each other. Look at them, that's another parallelogram. So AL, so AL is equal to DE. That's because of the opposite sides of a parallelogram. And we know that LM is equal to EF. Again, same reason. Then DE is equal to EF. So those two are equal. We know that that's equal to that. We know that that's equal to that. Therefore, DE is equal to EF. Hope all that's okay. Taken a good few minutes to go through it. I went through it really slowly. It's not as difficult. I just wanted to go through it in good detail.